Learn the basics of lung ventilator Aventa-M with this film that clearly demonstrates the equipment assembly and operation procedures, main modes and functions. This film neither constitutes the manual nor supersedes the induction briefing held by our specialists. Before using the ventilator, carefully study the operational manual. For details, contact the representatives of Ural Instrument Engineering Plant or visit website upz.ru. Lung ventilator Aventa-M is designed for performance of controlled and assisted ventilation for adults and pediatric patients having a weight of more than 5 kilograms in the operating rooms, resuscitation and intensive care units of medical facilities. Built-in turbine ensures high ventilator performance and allows to reach the peak inspiratory flow rate of up to 200 liters per minute. Big 12-inch high-resolution touchscreen, push-turn knob, and functional buttons are the components of user-friendly interface. To warn the user of any incident, lung ventilator Aventa-M features a 3-level system of visual and audible alarms. Prior to mounting lung ventilator Aventa-M, mobile trolley shall be assembled. For this purpose, first, mount and fix the trolley base with casters to the bottom side of the column. After that, fit the handle for moving the trolley into special slots on the rear surface of the column. Now, metal platform for the lung ventilator may be mounted and fixed. Depending on the lung ventilator position relative to the patient, install fastener of the circuit holder either to the right or to the left of the platform. Fit the breathing circuit holder into the corresponding slot and secure it in this position. Now, screw in the screws fastening the ventilator body from the bottom of the platform. For convenient installation, the screw edge shall slightly project above the surface. Now, open the box with ventilator. The box contains the operational manual and the data sheet for lung ventilator Aventa-M. Depending on the version, lung ventilator Aventa-M may be supplied complete with a respiratory humidifier, accessory for capnography, pulse oximetry, metabolic measurement, and esophageal pressure recording, various consumables. Fit respiratory humidifier into a special slot on the front surface of the mobile trolley. Install humidifier chamber on the heated platform. Install lung ventilator body on the platform, making sure that holes on the bottom surface of the ventilator match with projecting screws. Tighten the screws to ensure secure fastening of the lung ventilator on the mobile trolley. Connect power cable to the corresponding connector on the rear wall of the ventilator body. Secure the cable in a special clamp. Connect oxygen hose to the high-pressure oxygen connector. Install oxygen nipples at the other end of the hose. Connect capnography and pulse oximetry sensors to the corresponding connectors on the rear wall of the lung ventilator body. Carefully install expiratory valve diaphragm on the valve body, making sure that the diaphragm metal disc is outside. Insert expiratory valve into the ventilator body and rotate clockwise until it engages. Install metal grid and silicone cap to one side of the flow sensor, with the trade name applied. Install silicone sleeve on the other side. Install flow sensor into electric connector near the expiratory valve. Carefully shift the silicone sleeve from the flow sensor to the middle of the expiratory valve body, thus sealing the connection. Inspiratory and expiratory ports shall be fitted with bacterial and viral filters. Assemble breathing circuit in accordance with general recommendations. If nebulizer is used, connect oxygen tube to pneumatic nebulizer connector on the ventilator body. Incorporate the nebulizer in the breathing circuit on the inspiration line upstream of patient's Y. If capnography sensor is used, incorporate special adapter in the circuit between patient's Y and endotracheal tube. Install capnography sensor on the adapter and press slightly until it engages. Prior to the ventilator first use, its disinfection is recommended. During operation, external surfaces of lung ventilator, holder of breathing circuit, expiratory valve, patient's breathing circuit, moisture collectors, masks, humidifier chamber, flow sensor, capnography and pulse oximetry sensors, gas delivery hoses and connectors are subject to cleaning and disinfection. For details on cleaning, disinfection and sterilization, refer to the operation manual for lung ventilator Aventa-M and accessory. Dust filters on the rear wall of lung ventilator body shall be periodically cleaned of accumulated dust. Dust filters can be taken out by removing protective cover. To switch the ventilator on, set the switch with protective cap on the rear wall of the device to the operational position. Then, press On button above the lung ventilator screen. After a short-term system self-test, the lung ventilator switches over to the standby mode. Prior to ventilating a patient, certain tests and calibration operations shall be performed. These tests shall be performed after each replacement of a breathing circuit, flow sensor, or bacterial and viral filters. Press Tests key on the standby screen. Make sure the patient is disconnected from breathing circuit. Select the type of breathing circuit used, adult or pediatric. To start the tests, press button Continue. To calibrate flow sensor, interconnect the inspiratory and expiratory ports with a short tube with filters, as shown on the screen. Press Continue. The test result is displayed on the screen. To proceed to the next test, press Continue. In case of an error, follow the on-screen instructions. Prior to proceeding to leak test and pressure sensors calibration, assemble breathing circuit as shown on the screen. Close the Y from the patient's side. This can be done with the use of a plug or with hand while wearing sterile gloves. Press Continue. If the test has been completed successfully, press button Continue to proceed to the breathing circuit compliance test. It is a very short test, which shall also be performed with Y closed from the patient's side. The next test is breathing circuit resistance test. To start the test, press button Continue. Just like the two previous tests, the first part of this test shall be performed with Y closed from the patient's side. Upon completion of the first part, a request to open the patient's Y will be displayed on the screen. Press Continue and wait until the test is completed. Upon completion of all procedures, the system will display the performed test's results on the screen. To exit the test window, press button Finish. The ventilator is completely ready for operation. If you continue ventilation of a patient after a break, you can restore all ventilation settings by pressing button Previous Patient in the Standby Mode window. Ventilation mode can be set for a new patient using button New Patient in the Standby Mode window. A window for entering patient's information will be displayed on the screen. Patient name, age range, respiratory system condition specifics, sex shall be entered in this window. Using push-turn knob, select the patient's actual weight, age, and ideal body weight. The patient's ideal body weight may be determined based on the height displayed in a tooltip on the top during installation. Press button Continue and proceed to ventilation mode setting. The type of patient's connection to the ventilator shall be set in the following window. This can be endotracheal tube, tracheostomy tube, or mask for non-invasive ventilation. Besides, ventilation mode, type of mandatory breath, type of spontaneous breathing, type of trigger, tube resistance compensation shall be set in this window. Press the corresponding button and select the desired value in the opened context menu. The ventilator supports patient ventilation both in standard classic modes and in advanced smart modes of ventilation. Standard modes of ventilator include the following: assisted ventilation modes, assist control, and SIMV. These are classic modes of controlled ventilation familiar to every intensivist. One of the most important ventilation modes among standard ones is synchronized intermittent mandatory ventilation, SIMV mode. Further, we will consider it in detail. Also, standard modes include ventilation modes for supporting spontaneously breathing patients, SPONT, CPAP, and H-flow. The ventilator features two-level ventilation modes, allowing a patient to breathe with comfort at high and low pressure. These are standard two-level mode, dual level, and inverse mode with pressure release, APRV. Adaptive mode, Auto-MVG, is an advanced multi-purpose mode that maintains minute ventilation volume preset by the healthcare practitioner, irrespective of the changing respiratory system condition and spontaneous activity of the patient. Further, we will consider this mode in detail. Besides, it is possible to use previously saved ventilation parameters prepared for different medical cases by pressing button Ventilation Patterns. After selecting the corresponding parameters, press button Continue. When a new ventilation mode is selected, its indicator will be displayed in the upper left corner of the screen. To change the ventilation mode, press the indicator of the current ventilation mode. Make the required changes and press button Continue. After selecting a new mode, two rows of adjustable ventilation parameters will appear in the lower part of the screen. The main ventilation parameters are indicated in the lower row. They have big graphic controls and are continuously displayed on the screen. The ventilator sets the values of all parameters by default depending on the entered ideal body weight and individual specifics of the patient. Any of these parameters may be changed. Press the parameter you want to change and set the required value using encoder. The parameter being changed is displayed on the green background, and parameters that have already been changed are displayed on the yellow background. Additional ventilation parameters are indicated in the second row. They have smaller graphic controls, and when their settings are confirmed, they are no longer shown. They can be called up by pressing button Add Params. When changing certain parameters, tooltips with additional information corresponding to the displayed parameter value may appear above these parameters. In some cases, red tooltips may contain information about invalid parameter value. Direct control buttons are arranged from the top and to the right of the touch screen. Button for switching the ventilator on-off, switching over to standby mode. Indicating lights show ventilator 220 volts AC mains or battery operation. Button nebulizer with indicating lights. Button of audible alarm muting for 2 minutes. Button of low priority or inactive alarm reset. Button of manual mandatory breath. Button of touchscreen lock for protection against accidental settings change. Buttons of inspiratory and expiratory pause allow for inspiratory or expiratory breath hold of up to 30 seconds. Buttons of settings confirmation or cancelling. To the right of the main screen, there is a screen of the main monitored parameters. Any group of monitored parameters can be selected for continuous display on the run screen. Press one of the fields and select the required monitoring parameter from the drop-down list. At the top, near the current ventilation mode indicator, there is a button for switching over the run screens. Select the most convenient presentation model. By default, the main run screen is the screen with breathing curves. It is possible to set the color of the breathing curve, freeze the breathing curves for precise measurement of the required parameter at a particular time. Besides, it is possible to adjust the breathing curve scale and scanning rate. The next option is the loop screen. It is also possible to change the breathing loop's colors, freeze them for detailed study. Set the current breathing loop as the reference one to compare the same with the following breathing cycles. Besides, it is possible to select numeric parameter window that allows to obtain the maximum information about the current ventilation parameters. Then, there are trend windows, graphic and tabular. Graphic trend window allows to select the information display time in the range from 1 hour to 30 days and adjust graphically displayed parameter. Tabular trends represent the same information but in numeric format. Metabolism window allows to assess consumption and excretion of oxygen and CO2 during different time intervals, assess a patient's metabolism level and energy expenditure, which is very important for calculating of a patient's daily nutrition. The next group of run screens is merged under the common name multiscreen. It includes combined screens of curves and loops, curves and trends that combine the main screens described above. But the most interesting combination is curves, loops, and lungs. This run screen allows to customize the display of 3 breathing curves, 1 loop, as already been described. The main feature of this screen is schematic representation of patient's lungs. The lungs expand and contract synchronously with the respiratory movements of a patient. Patient's airway patency is indicated with a colored outline in the area of trachea and major bronchi. Wide green outline indicates good airway patency, low airway resistance. In case of airway patency impairment and increase of airway resistance, the outline changes to thinner orange one or to thin red one. In this case, it is necessary to check the breathing tubes for the absence of bending. Perform the airway sanitation. Pulmonary compliance is indicated on the scheme with a colored outline around the lungs. In case of excess compliance, the outline is outsized, hyperinflated. The normal value is indicated by a green outline around lungs with a physiologic form. In case of compliance impairment, the outline around lungs may change its color to orange and have a slightly angular shape. In case of substantial impairment, it may change its color to red and have sharp angles. If the ventilator is additionally fitted with pulse oximetry sensor, then indicator of oxygen saturation of a patient's blood will also be displayed on the lungs scheme. At normal SpO2 parameter values, the lungs will have the physiological pink color. In case of decreased oxygen saturation of patient's blood, or in case of a failure to measure this parameter, the lungs proportionally change their color to the shades of blue. In general, the multi-screen with schematic lungs representation allows to immediately assess the general condition of a ventilated patient. Another method of rapid diagnostic of a patient's respiratory system condition is the PV maneuver. It can also be accessed by pressing the Run Screen Selection button. The use of PV maneuver requires a completely passive patient with stable hemodynamics. The maneuver allows to build up a static pressure-volume loop and determine the optimal level of PEEP for this patient. Before starting the maneuver, carefully study the warning in the pop-up window. Set the initial and maximum levels of the used pressure basing on the safe values for a patient, pressure rise rate, and maximum allowable volume within this maneuver. Press button Start. Upon completion of the maneuver, determine the value of optimal PEEP and peak pressure following the shape of the obtained loop. Let's consider one of the most advanced ventilation modes, adaptive mode Auto-MVG. This mode supports adjustment of most of the controlled parameters, such as mandatory breath rate, respiratory volume, peak pressure, inspiratory time, etc., to changing respiratory mechanics and spontaneous activity of the patient. This mode is designed for achieving the preset minute ventilation volume at minimum possible load on the respiratory system, which ensures comfort to a patient. In this mode, the main controlled parameters include minute respiratory volume expressed in percent of the normal value calculated based on a patient's ideal body weight, PEEP level, and percentage of oxygen in the respiratory gas. An important additional parameter is the respiratory quotient VT max. It is preset in milliliters per kilogram of the ideal body weight and limits the maximum respiratory volume. Operation of this mode is demonstrated in Window Ventilation Map. This run screen combines 3 graphic windows that indicate ventilation, oxygenation statuses of a patient and his or her spontaneous activity. The current ventilation status is displayed in the ventilation window in the form of a ring. The boundaries for safe ventilation of a patient, considering respiratory mechanics and mode settings, are indicated with a red color. Ventilation goal is indicated with a cross. This ventilation goal represents an ideal ratio of respiratory volume and rate when the preset minute ventilation volume is achieved with minimal effort. With every breath, the ventilator gradually adjusts the respiratory volume, inspiration pressure, and respiratory rate in order to achieve the optimum ventilation. When changing the respiratory mechanics parameters or adjusting the preset minute volume, all calculations are updated and the ventilator readjusts ventilation settings to new conditions. One of the most advanced options is automatic adjustment by the ventilator of PEEP parameters and percentage of supplied oxygen in accordance with International Ventilation Protocol ARDS-NET. If your ventilator is fitted with pulse oximetry sensor, open System Settings and go to tab Auto. Activate buttons of Automatic Control FiO2 and PEEP. Based on the pulse oximetry sensor readings, the ventilator will start to gradually increase or decrease the specified parameters in accordance with the protocol recommendations. It is visually represented as arrows rotating around the changed parameters. Timer above the parameter indicates the time after which the next adjustment will be performed. All modes support these options, but in combination with Auto-MVG, they ensure almost complete automation of patient ventilation. Open tab Procedures in the lower right corner of the screen. Lung ventilator Aventa-M supports the following procedures. Nebulizer therapy. Clicking will call up the window with the regulators of therapy duration and supplied oxygen flow. Suction procedure includes 3 stages. During the first stage, the ventilator performs patient pre-oxygenation for 3 minutes by means of increased oxygen content in the respiratory gas. After that, the patient tube may be disconnected from the breathing circuit, and suction procedure may be performed. When the patient is disconnected, the ventilator stops ventilation and switches over to idle mode. At the last stage, after connecting the patient tube to the breathing circuit, the ventilator performs post-oxygenation for 3 minutes. Lung recruitment maneuver is a complicated 2-stage long-term maneuver that shall be performed in patients with acute respiratory distress syndrome to recruit collapsed alveoli, thereby promoting gas exchange. At the first diagnostic stage of the maneuver, set the maximum PEEP pressure that the ventilator will use during the maneuver, step of PEEP change, and number of breaths after which the ventilator will change PEEP value. Press Start. Upon completion of the maneuver, using 2 cursors, determine the maximum allowable level of PEEP and the minimum level following the shape of the obtained breathing loop. Enter the obtained values in Window Alveolus Open Procedure and start the second therapeutic stage by pressing button Start. For details of this procedure, refer to the operation manual. Simplified recruitment procedure is much simpler and constitutes in periodic increasing of PEEP level by 3 cm H2O for 2 breaths in a row. Long ventilator Aventa-M features a 3-level system of alarms. Alarms of low, medium, and high priority are displayed in the upper right corner of the screen and differ by the background color and sound. Go to tab Alarms in the lower part of the screen to set the alarm limits for patient ventilation. The main adjustable parameters of the ventilator alarms are grouped together in 2 tabs. Alarm signal volume and delay of alarm actuation for non-invasive ventilation can be adjusted in the 3rd tab. Study the list of alarms and possible methods of eliminating their causes specified in the operation manual. Any change of long ventilator Aventa-M settings, as well as alarm actuation and information about alarm cause elimination, are recorded and stored in the events log with a capacity of up to 5,000 events. The log can be called up by pressing button Event Log in the lower part of the screen. Press button Settings in the lower part of the screen. System Settings window of long ventilator Aventa-M will be displayed. The first tab, Info, contains information about active options, software version, ventilator operation time since last maintenance expressed in hours. In the second tab, Common, it is possible to adjust the ventilator system time, temperature, and humidity compensation, compensation of leakage in the breathing circuit, auto-scaling of curves and loops. If long ventilator is used together with a low-pressure oxygen concentrator, it is necessary to allow usage of low-pressure oxygen. Here, it is also possible to change the color of the displayed breathing curves depending on the respiratory phase and night and day color theme of the main screen. In tab Display, it is possible to adjust the run screen brightness. Tab Apnea is intended for setting protective mode apnea as an additional one for the modes with spontaneous ventilation. Set the limit of apnea alarm actuation, type of mandatory breath, machine breath rate, and additional parameters. Go to tab CO2. Here, it is possible to switch capnography sensor on and off. Calibrate the sensor. Set CO2 parameter measurement in % or millimeters of mercury. In the last step, Auto, it is possible to switch on automatic calibration of flow and oxygen sensors. To shut down the ventilator, press button Off on the panel. Select item Power Off. Once the screen has turned off, press the power button on the back of the ventilator. It is important to monitor the battery charge level and recharge it if necessary. If the ventilator has not been used for 1 month, recharge the battery. Today, you have become familiar with correct assembly, connection, and adjustment procedures of long ventilator Aventa-M, as well as its mode selection and operation. We hope that the ventilator usage has become more clear. For details, contact our managers if the ventilator was installed by our specialists, or visit website of Ural Instrument Engineering Plan www.upz.ru.